Trigonometry, Chapter 5, Trigonometric Identities, Section 2, Verifying Trigonometric Identities, Video 4, Verifying an Identity, Example 3. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. As mentioned before, the rest of the videos in this series are just verifying identities, so they do not directly connect to the previous videos. So let's jump right into it. Verify the identity. Cotangent of theta plus tangent theta equals secant theta cosecant theta. We have two primary strategies at this point. Number one is to start with the more complicated side and try to turn it into the simpler side. And number two is to transform everything into sines and cosines. We could clearly transform all of these into sines and cosines, but which side is more complicated? It's really a matter of opinion. The left side is an addition problem. The right side is a multiplication problem. They both contain two trig functions, so it's not necessarily clear if one of these is more complicated than the other. So I'm going to introduce a new third strategy that goes along the lines of the first strategy. The first strategy is turn the more complicated side into the less complicated side. But a different strategy is manipulate both sides separately and transform them into the same expression. So in other words, instead of turning the left into the right or the right into the left, we're going to turn the left and the right both into a new thing that match. And as long as all of our moves are reversible, that will suffice. So we're going to attack the left side and then attack the right side. Let's attack the left side, cotangent theta plus tangent of theta. Now, if we were to do something trigonometrically, our only choice at this point is to use a two quotient identities. Cotangent of theta is cosine theta over sine theta. That says cosine. Truth be known, I started writing sine and then I had to backtrack and spell cosine. And then tangent theta is sine theta over cosine theta. All right, algebraically, we have to get common denominators. So if we're going to add these, we need to multiply both sides of the first fraction by cosine theta, both sides of the second fraction by and both sides of the second fraction by sine of theta. And the minute I do this, I realize that I can transform this into the right side. I'm going to push this to a certain point. Let's see, what do we get here? Our common denominator is sine theta cosine theta. On the top of the first fraction, we get cosine squared theta. And on the top of the second fraction, we get sine squared theta. But the numerator is now just a Pythagorean identity. Going along the lines of citing our moves, to go from cotangent to where we did was a quotient identity, and to go from tangent to where we did was also a quotient identity. And then we're about to take advantage of a Pythagorean identity, because sine squared plus cosine squared is equal to 1. Now, there's a much cleaner way to do this. Unfortunately, I limited myself to one screen. So I think after this video, I'll insert an extra video that shows you a much cleaner way to organize this work. So at this point, we've transformed the left side into 1 over sine theta cosine theta, which is probably transparently the right side. But to show you the meet in the middle strategy where you work both sides, let's work the other side, secant of theta times cosecant of theta. Well, using two reciprocal identities, secant is 1 over cosine of theta times cosecant is 1 over sine of theta. And then we can multiply the two fractions together. 1 times 1 is 1. And on the bottom, cosine times sine in no particular order is sine theta over cosine theta. So we turn the left side into one thing. We turn the left side into one thing. And then we turn the right side into that same thing. As long as all of the moves are reversible, and they are, this is sufficient to verify an identity. We didn't turn one into the other, we turned both into the same third party. I'm going to insert an extra video showing you a better way to organize this work, because again, I've limited myself to this one screen.